Okay, section 8.7 is multiplying polynomials. So we're going to do a quick refresher of our last section, which was multiplying a polynomial by a monomial. So if I have a monomial and I multiply it by a polynomial, I have to distribute, and I'm going to multiply it by each term. So 2x times 3x squared plus 2x times 4x plus 2x times negative 5, and I get 6x cubed. Remember, I multiply the coefficients. X times x squared, I have to add my powers, plus 8x squared minus 10x. And that's my solution. Okay, so now in this section we're going to first look at multiplying a binomial, two terms, by another binomial. And again, we're going to use the distributive property. But now I have two things that need to be distributed. So first I'm going to take the x and distribute it to everything to its right. And then I'm going to take the plus 3 and distribute it. Okay? Then I've got to distribute my monomial again. X times x is x squared. X times 2 is 2x. Plus 3 times x is 3x. 3 times 2 is 6. And then the last thing will be to combine any like terms to simplify. Okay, so again, I distributed the x to both pieces, the 3 to both pieces, and then distributed just like we did in the last section. Now there are several ways to multiply a binomial times a binomial. This is one of them. We're also going to look at multiplying two binomials using a vertical alignment. So this time I'm going to put them on top of each other, kind of like you would have multiplied two-digit numbers. Okay? So when you multiply two-digit numbers, you multiply 12 times, say, 16, right? And then we multiply the 6 by the 2, the 6 times the 1, then the 1 times 2, and the 1 times 1. So we're going to do the same thing with binomials. So 2 times 3 is positive 6. 2 times x is 2x. And you notice that unlike, let me do this again, unlike when I'm multiplying numbers, when I multiply 3 times 1 I write 3, and 3 times 2 I write 6. I don't have to put a plus or minus between them, but when I'm multiplying terms of a binomial, I have to keep the terms separate. Okay, then just like my multiplication over here, 2 times 1 is 2, you notice how I moved over a space, right? So x times 3 is 3x, and we need our plus sign in front of that, and x times x is x squared. Then I'm going to add going down 6, positive 5x, x squared. And you notice we get the same answer this way as we did when I used the distribution method. So this is a second way of multiplying. The last way is the most common way that we're going to use when we multiply two binomials, and that's a method called FOIL. FOIL stands for first for the F, O stands for outer, I stands for inner, and L stands for last. So it just gives me a method whereby I can remember exactly what I have to multiply. So first, that stands for the first term in each binomial. So for first, I'm going to get x times x, or x squared. Outer, the two outside terms, x times 2. Again, I need that plus sign in there. Inner, 3 times x. And last is going to be the 3 times 2, or 6. So first, outer, inner, last. First term times first term. The outside terms multiply together. The inside terms multiply together, and the last term times the last term. And again, then I need to combine any like terms, And you notice that once again we've gotten x squared plus 5x plus 6. This is the method that most people like for multiplying two binomials. It only works, FOIL only works, if you have a binomial, two terms, times another binomial, two more terms. But it's a really handy tool to use. All right, let's apply this to something. The area of a trapezoid is A equals 1/2 the height of the trapezoid, which is a line drawn perpendicular from the top to the bottom, times the first base plus the second base. And our two bases are the bottom and the top of the trapezoid. So we want to find an expression, not a value, but an expression for the area of the trapezoid. So area equals 1/2 the height times b sub 1 plus b sub 2. So area equals 1/2. My height is x plus 2. B sub 1 is 2x plus 1. B sub 2, that's plus, not times. Okay, and my pen's getting a little iffy here. So plus base 1 plus base 2 plus 3x minus 7. So I'm going to do my addition first to get a nice, neat term for the sum of my bases. 2x plus 3x, I'm not multiplying now, I'm adding. 2x plus 3x is 5x. 1 plus a negative 7 is negative 6. Now, I'm going to FOIL first before I distribute the 1/2. If I distribute the 1/2 first, I'll have to work with fractions. So 1/2 times FOIL first is x times 5x, 5x squared. Outside is x times negative 6, negative 6x. That's my outside. Inside, 2 times 5x, that's positive 10x. And last is my 2 times negative 6, or negative 12. So, clean up the inside by combining like terms. Negative 6x plus 10x is 4x. And the last thing I'm going to do is distribute my 1/2. 1/2 times 5 is 5/2 x squared. 1/2 times 4 is 2x. And 1/2 times negative 12 is negative 6. And that's the expression that represents the area of the trapezoid. So we are going to be doing some geometry. We'll talk in class about which formulas I expect you to know. We've already talked about this a little bit. Okay, so that's all a binomial times a binomial. Whoops, where'd my video go? Okay. So, now we're going to talk about multiplying larger polynomials. In this case, we have a binomial times a trinomial. We're still going to distribute. So once again, each part of the first polynomial will be distributed over the second one. So 4x times 2x squared minus 5x plus 3. My second term plus 9 times 2x squared minus 5x plus 3. Now I have to distribute again my monomial times my trinomial. 4x times 2x squared is 8x cubed. 4x times negative 5x is negative 20x squared. And 4x times 3 is plus 12x. I'm going to go on to the second one. Plus 9 times 2x squared is 18x squared. 9 times negative 5x is negative 45x. And 9 times 3 is a positive 18. I've got to look for some like terms in here. 8x cubed, there are no other x cubes. There's my x squared. Negative 20 plus 18 is negative 2. Remember, when I add like terms, I don't change the variable component. Positive 12x minus 45x. That's negative 33x. See can get this to write better, negative 33x, and then I have a constant at the end, plus 18. Oh, that is negative. Sorry, my pen's causing me some trouble. All right, so again, distributing the 4 over everything and the 9 over everything, and then combining like terms. Okay, try this one on your own. This is a trinomial times a trinomial. Try it on your own and then come back to the video. Okay, so I'm going to take my first term and distribute it over all of these. So x squared times 3x squared plus 4x plus 5. I'm going to take my negative 2x and distribute it over 3x squared plus 4x plus 5. And then I'm going to take my positive 1. So positive 1 times 3x squared plus 4x plus 5. So let's distribute again. I'm not going to write everything out. We're just going to do it in our heads. X squared times 3x squared is 3x to the 4th. X squared times 4x is positive 4x cubed. X squared times 5 is positive 5x squared. Now watch this negative sign here. Remember, this is taking a negative 2x each time. So negative 2x times 3x squared is negative 6x cubed. Negative 2x times 4x is negative 8x squared. And negative 2x times 5 is negative 10x. The last one is 1 times all of this. 1 times anything doesn't change it. So 3x squared plus 4x plus 5. Now I've got to gather my like terms, and there are a lot of them. So in order to not miss anything, I like to keep track by either crossing them out or circling them or some other method. 3x to the 4th, that is the only x to the 4th term, so it's the only one I need. X cubes, let's see, there's an x cubed, there's an x cubed, and that's it. 4x cubes minus 6x cubed, negative 2x cubed. X squareds, 5x squared minus 8x squared plus 3x squared. 5 minus 8 is negative 3, plus 3 is 0. I don't have any x squareds left. Negative 10x plus 4x, negative 6x, and my lonely 5 at the end. So it's a lot of work. You got to keep track of your terms, watch your signs, and that's it for the lesson.